So after discussing colors, we have to discuss the chemistry of different transition elements compounds. Like I mean to say, first of all, we would be discussing the chemistry of copper. Chemistry of copper means that first of all, we have to discuss the color of the copper sulfate. Like we have two types of copper sulfate. We have hydrated copper sulfate, and then we have anhydrous copper sulfate. Okay. And then we have anhydrous copper sulfate, right? So anhydrous copper sulfate is white. Okay. Anhydrous copper sulfate is white, and hydrated copper sulfate is blue. And not only this, in fact, we have to test the presence of copper 2 plus. And if you remember in the previous classes, like in IGCSE in paper 6, or if you are from O levels, paper 4, ATP paper, so what we used to discuss? We used to discuss the, I can say, uh, we used to add sodium hydroxide, few drops of sodium hydroxide, then we used to add excess amount of, I can say, sodium hydroxide. Then we used to see, sometime we used to see the, I can say, blue precipitates. And after adding excess amount of sodium hydroxide, so then we used to see like sometimes the precipitates are getting dissolved, and sometimes we can say the precipitates are not getting dissolved. So it depends. So today we are going to discuss the same thing, right? uh, let's say chemistry of copper plus 2. Chemistry of copper plus 2. Uh, okay, so let me write copper plus 2. Yes. Mm, okay, then chemistry of copper plus 2. Copper plus 2 means that it is supposed to be Cu CuH2O6. And the overall charge is plus 2, right? And the overall charge is plus 2. Or if the overall charge is plus 2, so means that this is going to be blue in color. This is going to be blue in color. So basically, we have to test it after adding few drops of sodium hydroxide and an excess amount of sodium hydroxide. Okay. So let's say if I'm adding uh, few drops of sodium hydroxide, few drops of sodium hydroxide, and also we add few drops of ammonia as well, because both are bases, both are bases, by the way, both are bases. So few drops of sodium hydroxide, right? So let me tell you one thing before going to do this. Whenever we can see the charge on any complex, so that's going to be soluble. Remember, it's a very important point. Whenever you can't see any charge, so that's going to be solid. Remember, let me note it down. If if there is a charge, if there is a charge on a complex, then it's soluble. And in case of no charge, In case of no charge, then it would be solid. In case of no charge, then it would be solid, right? Now I'm adding few drops of sodium hydroxide. It means that I'm going to add OH minus, right? So what would be the equation? Copper H2O6 2 plus, right? I'm adding 2OH minus aqueous. Then copper H2O 4 and OH2 to the power 0. It's going to be solid plus 2H2O liquid. 2H2O liquid. So this is going to be, this solid is going to be, it's called blue precipitate. It's called blue precipitate, blue PPT. Okay, it's going to be blue PPT, right? Or let's say if you will be adding, and we can also write this one as copper. I can do this, or I can also write this as CuOH2 dot 4H2O, right? Okay. So now what I'm doing, I'm going to heat this. If this is heated, so what would be observed? I'm going to talk about this one. CuOH2 dot 4H2O is going to be heated, so I would be getting this one. It's liquid. And by the way, I'm gentle heating, right? Like mild heating. So this is going to be solid. And what if I'm going to provide a strong heat to this one? So you will see that it's a strong heating. It's not mild, it's a strong heating. So it's gonna be copper oxide plus water. Again, this is going to be solid. And this is black solid. And this is what? This is black solid. Black solid. I'm going to write each and every possibility. When you will see the question, so you will be able to write each and everything. And remember, you can notice one thing in this reaction. I'm talking about this one. Coordination number is not changing. Coordination number is 6 and this is 4 plus 2. It's also 6. Coordination number is not changing. Remember, coordination number is not changing in this reaction. Okay. So initially it was pale blue solution. And afterwards we got the pale blue precipitates, right? Right. Then let me tell you how you can see the product, like what's going on in this reaction. Okay. So the thing is that if you can see, like let's say, uh, let me explain over there. Let me explain over there what's going on in this one. Basically, what I did when I have added water molecule into this complex, listen carefully, right? It's very important. When I have added water into this one or sodium hydroxide, so initially this was the complex. It's a tetrahedral. It's a tetrahedral complex like that. For tetrahedral, it has a 6 covalent bonds. So this is like that. Okay. Now we have a base. Now we have OH negative ions like that, as this was two OH negative ions. Okay. Um, so what this OH negative ion would do, by the way. So as we know that this is going to be partial positive, partial negative, partial positive, partial negative, partial positive, partial positive. Okay. Due to the highly negative oxygen element, oxygen atom, so it's going to be partial negative. So as a result of this, they will react with each other. They will react with each other. Same goes for this one. So water is removed. When H plus will react with OH minus, so water is removed. So you know what would be the remaining one? You know what would be the remaining one? Yes, it's going to be the same thing, but with OH ion. See this one? What would be the remaining one? I can say, uh, yes, okay. Uh, I can see this. I can see this. The same. OH and OH, right? And water molecule is removed. Hopefully you are getting my point, what I want to say. Okay, this is very easy. This is very easy, isn't it? So basically, I want to say that how we got the OH ion, how we got the OH ion like that. So 4 water and 2 OH. That's what I wrote. Okay. So and then uh, after that, after that, what if what if I'm going to add sodium carbonate? What if I'm going to add sodium carbonate? Let's say adding sodium carbonate. By the way, sodium carbonate is also a base. And this is acid-base reaction. This is what? This is acid-base reaction. Remember, this is acid-base reaction. Okay? Acid-base reaction. This is acid-base reaction. Okay. So what if I would be adding sodium carbonate into the same complex? What if I'm going to my screen? What if I'm going to add sodium carbonate into this? Then what would happen? See this. Copper H2O6 with the 2 plus charge on the complex, adding sodium carbonate and Na2CO3. What would happen? It's going to make sodium sulfate. It's going to make sodium sulfate, and also you will see some sort of copper carbonate as well, and you will see water as well. Let me explain it, what's going on in this reaction. And by the way, if you're thinking, sir, where the sulfate comes from, of course, in the reactant side, there is no sulfate. So the answer is that in the reactant side, I just wrote in an ionic form. I just wrote in an ionic form. If I would be writing in full form, then you will see. I'm going to write in full form. So in actual, this is going to be the sulfate ion. If I would be writing the sulfate ion, then overall I'm not supposed to write down the charge, by the way. Got it? Like sometime we write MnO4 minus, MnO4 minus, but this is an ionic form. If you will be writing KMnO4, K is positive, then overall you are not supposed to write down the charge. That's the concept. That's the concept. That's why if you will be writing sulfate, so no need to mention the charge. Then no need to mention the charge, right? So initially the color was pale blue solution, right? And afterwards I got copper carbonate that is solid, and this is green precipitate. You need to remember, and you need to memorize the color, by the way, right? And what's going on in this reaction? What's the type of reaction? What's the type of reaction? Copper is with carbonate. Initially, the copper was with water. Water is a ligand, carbonate is a ligand. So ligand substitution reaction. It's a ligand substitution reaction. It's a displacement reaction, by the way. It's a displacement reaction. So I'm writing that it's a displacement reaction. Okay, it's a displacement reaction. Okay, and then copper carbonate. What do you think about copper carbonate? It's a basic. It's basic in nature. It's basic in nature, right? So what if I'm going to add uh, ethanoic acid in this base? What if I'm going to add ethanoic acid in this base? Then what would happen? Ethanoic acid in this base, then what would happen? So basically, after adding ethanoic acid in this one, of course, there would be a neutralization reaction. Okay, there would be neutralization reaction. So when copper carbonate reacts with ethanoic acid, CH3COOH, it's going to form CH3COOC, calcium, and water along with carbon dioxide. Okay, so what can I write? This is what this was solid. This was green PPT. This was green PPT, and there is nothing in the product side. So we can see effervescence due to CO2, and I can say green PPT dissolves. It will disappear, by the way. Okay. And then after discussing, and this is a neutralization reaction. Okay. Or what if I'm going to add concentrated hydrochloric acid? What if I'm adding concentrated hydrochloric acid? What would happen then? After adding sodium carbonate, now I'm adding concentrated hydrochloric acid. Concentrated hydrochloric acid. So what would happen? So I would see that copper H2O6, copper H2O6 charge is +2. I'm going to add chloride aqueous. I would see that copper chloride forms. Overall charge is 2 minus. It should be 4Cl minus to balance this equation and 6H2O. This is aqueous because it has a charge. I told you this one. So it would be yellow in color. Pale blue solution to yellow color. Okay. Now you're looking that it's also a substitution reaction, isn't it? It's also a substitution reaction because water was a ligand and chloride is also a ligand. So water is going to displace, water is going to displace the chloride ligand. So water is going to like the chloride is going to displace the water ligand. So I can say it's a ligand substitution reaction, isn't it? It's a ligand substitution reaction. It's a ligand exchange reaction. Same thing. Okay, done. Yeah, also you can see the geometry has been changed. It was octahedral, it's tetrahedral. It was octahedral, it's tetrahedral. Okay. Okay. Now, now I can say that it's going to change from octahedral to the tetrahedral, in the tetrahedral, what's the bond angle? 109.5. And what's the bond angle in octahedral? 90 degrees. So I can say when the bond angle is higher, so the ligands are far away from each other, so there would be less repulsion between the ligands. So I can say the complex is going to be more stable, isn't it? Okay. So you must know this thing. And afterwards, I can say, uh, what if, what if I'm going to add EDTA? What if I'm going to add EDTA? Let's say I'm saying that I'm going to add EDTA 4 minus. Then what would happen? Then what would happen? So again the same complex, right? The same thing, the same thing, okay? So you can see again the coordination number is same because EDTA is a hexadentate ligand. It's a polydentate ligand. The geometry is not going to change, but the color is going to be more paler. It's not the same. It's not the same. It's pale blue. It's more pale blue. Like I can say the light pale blue. Okay, the color is going to change. So, and this is all about the chemistry of copper. It's all about the chemistry of copper, right? Okay. And then what if I'm adding potassium iodide? What if I'm adding potassium iodide? So see this? Adding potassium iodide. The reactant is same, okay? It's all about copper plus 2. The reactant is same. So copper sulfate plus Ki. Copper sulfate means this one. The same thing, but in this I want to make you understand something different. So it would be forming copper iodide, okay, along with like potassium sulfate. Again, it's a displacement reaction, and you will see I2 as well. And I2 is aqueous. This is copper 1. In this, the oxidation state of copper is plus 1. So this is going to be white PPT. It's solid. It's what? It's solid. And this is going to be aqueous. Then you are supposed to balance the equation. So I would do this one, and then I can say this one, or it's going to be 2 copper sulfate. It's the balanced chemical equation. And for iodine, I can say brown solution. Observation is very important in this. Remember, observation is very important, right? So after this, what if, uh, let's say, basically in this chapter, you will see different questions. Examiner would be asking equation, examiner would be asking about the like the observation sometime, and sometime he will be giving you to complete the equation. Okay, in that equation you must know. Also he would be asking about the type of reaction as well. Okay, and the last thing that we need to know is what if I'm going to add ammonia. Adding ammonia. Adding ammonia, right? So few drops of ammonia, then excess ammonia. By the way, there would be the same reaction. I'm saving your time. Same reaction, because this is also a base. Sodium hydroxide is also a base. Okay. So reaction would be the same. Okay, 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 okay. Yes. Everything is same. Everything is same, but I can write uh, just a minute. Yes. It's not water. It would be ammonium ions, or this would be ammonia. This would be ammonia aqueous. Okay. Again, I can see the dark blue precipitate. Initially, I was getting pale blue precipitate in the case of sodium hydroxide. Okay. So, and then what if I'm adding excess ammonia? What if I'm adding excess ammonia? So after adding excess ammonia, you will see after adding excess ammonia, then I can say excess ammonia. So for excess ammonia, we will see that. And by the way, this is again acid-base reaction. This is again what? It's an acid-base reaction because ammonia is acting as a base in this. Ammonia is acting as a base in this. Okay. So that's why we are getting the same product. If you remember in the case of copper plus 2, so we were getting the same product. So I have explained why that was acid-base reaction because OH negative is going to react with the H positive ion, right? So what if I would be adding like concentrated ammonia or I can say excess ammonia. So we will see this one. This would be the product. So I can see the dark blue solution. I can see the dark blue solution. Okay. And it was dark blue PPT. Sorry. It was dark blue PPT. So PPT is getting dissolved. So PPT is getting dissolved. Okay. So that's all about the chemistry of copper plus 2. That's all about the chemistry of copper 2 plus, or I can say plus 2. Then after copper plus 2, we have to discuss the chemistry of cobalt 2 plus. Okay, the same thing, but with different colors. Everything would be the same, like the reaction, like the type of reaction, or I can say the color of complexes. Everything, like I can say, would be the same. Okay, it would be again time taking.